Hey there, students. Today we're going to look at the last part of drawing VSEPR. So this is examples 2. Okay, so yes, that infers there's an examples 1. If you haven't watched that video, or were in, you should have been in class that day, but if you missed both, then stop this video because this will make no sense. You need to go back and do that other video. Please note I've got my handy dandy chart going on here, and I'm going to be using that later to fill in the electron geometry and molecular geometry. Today I need to introduce you to 5 elements that are super special. Call them the synapse elements. These elements are really hungry for electrons. They are monstrously hungry for electrons. So I call them the synapse because it kind of sounds like Cyclops. And I can warn you to watch out for these synapse elements. Okay, because of their high electronegativity and their small size, these 5, and only these 5, are going to be special in that they are guaranteed to achieve an octet. Now that's what they do in nature, so as I do a drawing, I need to be sure in my drawing that I'm showing that. So what you need to be aware of is I'm going to add steps today to what we were doing last time. So let's get into this. And please note, I'm starting the way we started last time. So again, this should not be the first video ever you're watching on VSEPR. This should be the second one. Okay. So here I have for carbon, 6 for each oxygen. That's a total of 16. I'm going to divide by 2, and I can show 8 pairs. So carbon in the middle, it is least electronegative. It's also like the symmetry works out that way, so hopefully that's not anything you have a question over. Notice I drew my bonds without thinking, like I did last time. I'm drawing my lone pairs, and please note I'm using pencil. I'm drawing lone pairs like last time, okay? And I did all of this just like I did last time without thinking. Now I pause just like last time, and I ask how many pairs am I showing? 1, 2, 3, 4, 5, 6, 7, 8, and I can show 8, so yes, I am good to go there. So nothing has changed so far. It is once I finish all the steps from last time, now I'm going to ask myself, are one of the synapse elements in the middle? The answer to this first if question is yes. Okay, so I first have to, if it was no, I'd be done. So yes, I have a synapse element in the middle. Next question I ask is, does it have at least an octet? So what's that mean? Could it have more? Yes, it could. It'd be fine. I'd be done. It's if it has less that I'm worried. So does carbon have an octet? Well, let's check it out. I only see 4 electrons, not an octet. 2 bonds is 4 electrons. Remember, each line is a pair. So no, I do not have an octet. So I need to achieve an octet. The way we're going to do this, okay, and it only happens with these 5, and it only happens with others of these 5, is I'm going to use my eraser. That's why you really want to be using pencil. And I'm going to make a double bond. And has that achieved an octet? Well, let's find out. Well, we're getting closer, aren't we? 2, 4, 6. I now have 6 electrons around the carbon, but I do not have an octet. Now, I want to pause and show you oxygen is still good. It still has 2, 4, 6, 8 pairs as well. So the octet around the outside is always there, always. And we're not doing anything to change that the outside ones have an octet, except for hydrogen. Here's the thing. I need one more bond. I could, on this same oxygen, erase a lone pair and make a triple bond, but nature likes symmetry. So I'm going to over here instead. I'm going to do that. Okay. Valence shell electron pair repulsion says electrons are going to repel as much as possible. Maximum repulsion is having a double bond on this side and a double bond on this side. Not maximum repulsion would be having a triple bond. Okay, that's a lot of electrons in one region. And so when we can avoid that, that's what nature's going to do. And you're going to see it can't always be avoided, but that's why I chose to make it symmetrical, put a double bond on both. Okay, now I'm actually done. I have achieved an octet on carbon. Check this out. 2, 4, 6, 8. Carbon has an octet. It works really well for carbon. I'm all done. I want to reiterate this. I started with the old steps. After doing all the old steps, now I asked, is there a Synops element in the center? Yes. Okay, I didn't do anything more until I asked that question and the next one. Does the Synops element in the center have an octet? The answer was no, so I got it there. What if the answer was no, it's not a Synops element in the middle? Then I'd be done, just like last time. Nothing new there. What if it did already have an octet? Then I'd be done. Nothing new there. Okay, so please, please, please catch, there are 2 questions to be sure you ask yourself before you move forward in making any multiple bonds. Now I'll come back to this in a minute. I wanted to show you another version, another time of doing this. Okay, so hydrogen's a 1, carbon's a 4, nitrogen's a 5, that's 10. And that's going to give us 5 pairs. Well, I don't know if I have 5 pairs shown yet. There we go. Okay, so hydrogen, carbon in the middle because it's least electronegative, nitrogen. Bonds like normal. Lone pairs on not hydrogen like normal. Hydrogen never gets lone pairs, reminder of that. And then I count my pairs like normal. 1, 2, 3, 4, 5. And yes, I have 5 pairs. So yes, I made it there. All right. Now, after I'm done with all the old steps, now I ask, is a Synops element in the middle? The answer is yes. Okay. Now I ask, does that Synops element in the middle have at least an octet? 2, 4. No, it does not. I need to fix that. Okay, let's fix it. Now notice, obviously, hydrogen has no lone pairs for me to erase, so I'm going to take from nitrogen. But even if this was another element, okay, again, multiple bonds only form between these 5. So no other elements other than these 5 would I be doing a multiple bond on either. So please watch out for that. It is just these 5 that do this multiple bonding thing. Is my carbon having an octet now? Well, it has 2, 4, 6, but it does not have an octet, so I'm going to do it again. And there we go. And now, does my carbon have an octet? Yes, with a single bond and a triple bond, it has an octet. Is my nitrogen still good? Well, as I mentioned earlier, we're not messing with anything on the outside in a way that changes it. 2, 4, 6, 8. It still has 8. It's just needing to share more so everyone gets an octet. And I hope you've noticed, we would call these double bonds, and we would call this a triple bond. And so we have 1 of each. Okay, now before we move on to more examples, I want to show you how we look this up in the chart. So we got my chart here, okay? And my chart says electron domains. Electron domains are regions around the center atom, regions of electrons. Notice I'm going to count this. You wouldn't have to circle it yourself, but notice I have 2 regions around this carbon. Yes, those are double bonds, but they don't count double. They only count once because they're in the same region. That second bond's in the same region as the first bond, so it only counts once. So it's really not a total of pairs. It is a total regions of pairs. All right, so the regions, that's why we call it electron domains, the domains. This has 2 electron domains as well. One's a single bond, one's a triple bond. That doesn't matter to the count. 2 regions, 2 domains. So both of these have 2 domains. None of the circled domains contain a lone pair, so it's a 2-0 combination. So I'm going to write in here, I'm going to write in linear, and linear, and linear, because it's the same, and linear. And there we go. All right. So very, very careful that you count multiple bonds once. They're regions of electrons. They're domains. They're not individual bonds. All right, we're going to count SO2. So sulfur's a 6. Each oxygen's a 6. That's 18. I'm going to show 9 pairs. All right, S would be in the middle. And I'm going to have an oxygen and an oxygen. And I'm doing all this like last time without thinking, because that's just what I always do. Now I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. Nope, doesn't work. I need to show 9. So leftovers on the inside. Okay, now I'm showing 9, just like last time. So again, today is not any change of the steps from last time. Do all those first. Now that I've done all the old steps, now I ask, is sulfur a synops element? Yes, it is. Does it have an octet? 2, 4, 6. No, it does not. So I need to fix this. Okay, I know how to fix this. Let's get rid of a lone pair and let's share it instead. There we go. 2, 4, 6, 8. All good. All right, so I'm all done. This sulfur has an octet. Wait a minute. Wait. Why did I put it over on that oxygen? Couldn't I have also done with that oxygen? Yeah, I actually could have, right? I could have double bonded on the right instead of on the left. That's a possibility as well. So I want to introduce you to the idea that with a multiple bond, with the double bond specifically, there would be a possibility that there's more than one place that double bond could be. In that event, you need to show the different possibilities. So it would actually take 2 pictures to be correct in my drawing for SO2. One showing the double bond on the left, one showing the double bond on the right. We call these resonance structures. Resonance structures. And we show resonance structures by putting this double-sided arrow in between them. So there's some compounds out there. Now again, if you caught my question earlier, it's when there is a double bond, there is the possibility that you will have resonance structures. Now let's pause and go back. Carbon dioxide has 2 double bonds. Was there a possibility of resonance structures? No. There was no other places I could put those double bonds. One on the left, one on the right was my only choice. Okay, but here, it's either on the left or on the right. So I do have resonance structures. So you want to, that's an additional step on top of all of this. Is the center atom a synops element? Does it have at least 8 electrons? If fixing it gives me a double bond, will there be resonance? 3 new questions to ask yourself now and take care of on top of the old steps. Now I want to show you how we're going to classify this. I have 1, 2, 3 electron domains over there on that picture, and I have 1, 2, 3 on that picture. Okay, so it'll always work out this way. The amount of electron domains will always be the same on each picture. So you only need to look at one picture for finding this information. But 3 domains, so I'm in a 3 region here, and notice one of those regions is a lone pair. So it's a 3-1 combination. So the electron geometry is trigonal planar, but the molecular geometry, if I were to ignore that lone pair, it's actually angular or bent. You don't have to write both. You just write one or the other, angular or bent. All right. So that's how we handle resonance structures. When would I expect a possibility of resonance structures if I have a double bond? But I still ask myself, could that double bond correctly go in more than one place? Again, multiple bonds only go between these elements. And so actually, let's look at that over here. Okay, so I've got PS3 minus. So phosphorus is a 5, each sulfur is a 6. Okay, 3 sulfurs, there we go. But I do have a minus, don't forget. I'm going to add 1. It is backwards for that. So that's 24, gives me 12 pairs. Okay, phosphorus in the middle, maybe something like this with 3 sulfurs. Not thinking, just drawing. because these are the old steps that we always do. Okay. Notice my old steps also include brackets and a charge because it has a charge on it. So I will include that. All right. So now that I've done all the old steps, let's see. Is phosphorus a SYNOPS element? Yes, it is. Is it having an octet? 2, 4, 6. No, it's not. Okay. So I will need a double bond. Where can I put the double bond? Any of 3 different places, huh? So I could double bond on the top, or I could double bond on the left. And notice the amount of dots appropriately reflects where the double bond is. Okay, so I really did erase the lone pair and move it over there. And I could be double bonding on the right. Why do I have 3 choices? Because all 3 are SYNOPS elements. What if one of these was not a SYNOPS element? Then it would not possibly do double bond or triple bond. Okay, again, multiple bonds only go between other SYNOPS elements. So I have my 3 different pictures to show that there's 3 different, and I have seen some compounds that you need to show 4 pictures for. So it's a possibility, but in this case I have 3 resonance structures. I'm going to put my double-sided arrows going on so it's clear these are resonance structures. All right. And how do I look this up? Well, I only need to look at 1 picture. So I would look up something with 1, 2, 3 electron domains. 0 of them are lone pairs. 3, 0. 1, 2, 3 regions, 3 electron domains, no lone pairs in any of these regions. And again, you don't have to circle it, but not wrong if you do. Go ahead and circle it if you need to focus like that. So I'm going to write trigonal, planar, and trigonal, planar. All right. And final one here for us. Okay. Arsenic is a 5. Each oxygen is a 6. And I have a charge, and it's backwards, so that's a +3. So if I do my math right, that's 26. Hopefully you're not trying to yell at the screen telling me I'm doing my math wrong. Let me double check. 6, 6, 6, 18. Plus 5 is, I can do this, 23. Plus another 3 is 26. Yes. Okay. So 13 pairs. All right. So I see arsenic with 3 oxygens. I'm not thinking, I'm just doing the old stuff. Okay, there we go. Old stuff done. Now I check, I count, which is still old stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pairs. Ooh, I'm not done yet. I have leftovers. Boom, there we go. 13. Okay, done. However, it does have a charge. I'm going to bracket and charge. Okay, so that's all old stuff. Now I ask myself, is arsenic in SYNOPS? Did you catch it? It's not. That's a no. Okay, I'm done. Like seriously, that's you're done. I put one of the old style to remind you, and in fact on your assignment you're going to have several old styles as well. You really have to, you can't just assume everything's going to have a double bond here or there where you feel like it, okay? There's really good questions you need to ask yourself to move forward. Is it a SYNOPS element? The answer here is no, it is not. So I am done. Okay. Notice how that also stops all the subsequent questions. The moment I say no, like it's all over. Normally I would ask myself, does it have a SYNOPS in the center? If yes, I keep going. If no, I'm done. Does the SYNOPS element have an octet? And if yes, I'm done. If it's more than an octet, I'm also done. I stop. I don't keep going. Only if I say yes here and no here do I keep going on to adding multiple bonds. So there's a lot of questions you need to ask yourself carefully to proceed and get it correct. This one I stopped here because the answer was no. and so I'm done. So there we go. Okay, again, how do we read this? 1, 2, 3, 4 regions of electrons, 4 electron domains. Of those 4, 1 is a lone pair. So it is a 4-1 combination. So I'm going to put tetrahedral here. And I'm going to put trigonal, pyramid, not bipyramidal. I almost wrote bipyramidal, pyramidal. And there we go. All right, so that is how we handle the synops elements. And again, you got to do all the old work first, just like we did here. And then after doing all the old work, then you start asking the 3 important questions that are new today. Don't forget, if it's a double bond, it will never work out with a triple bond. If there's a double bond, and that double bond can go in more than one place, then you'll have resonance, and you'll want to show the different resonance structures, whether it's 3 of them, whether it's 2 of them. It should be obvious as you work it out, because it goes between other synops elements. One last note, notice these had a charge, so I did resonate with the brackets and the charge as well. Okay, this did not have a charge, so there were no brackets or charges on either. Okay, that's like old stuff, but just wanted to remind you of how that worked. All right, so you've got an assignment of 20 of these to practice with. Some of them are old style, and you won't need 2 multiple bonds. Some of them have multiple bonds, but you don't need resonance, and some of them have multiple bonds, and you do need resonance. So you want to be sure you're keeping track of asking yourself our new really good questions and working your way through that way. I wish you luck.